Good morning, Bea. Carla!
Sir Louis said we should be in the tutorial room in a few minutes.
I'm so excited about the topic today. It's about quick mathematics.
I like the topic too. We started to learn some of the quick math techniques last meeting.
Like getting the product of two binomials horizontally and getting the square of a binomial. Let's review that first before we meet Sir Louis. To get the product of two binomials horizontally, we can use the FOIL method. F stands for the product of the first terms. O stands for the product of the outer terms. I stands for the product of the inner terms. L stands for the product of the last terms.
To square a binomial, we simply square the first term, double the product of the first and second terms, square the second term.
Let's try squaring a number mentally.
We begin with the rightmost digit.
1 squared equals 1. 3 times 1 doubled equals 6. 3 squared equals 9. 31 squared equals 961. Let's verify our answers using a calculator.
Two times 2 is equal to 4. 4 times 2 times 2 is equal to 16. Carry 1. 4 times 4 plus the 1 we carried is equal to 17. 42 squared is equal to 1,764.
Let's verify our answers using a calculator.
Three squared is equal to 9. 2 times 3 doubled is equal to 12. Carry 1. 2 times 2 is equal to 4. Plus the 1 we carried is equal to 5. 23 squared is equal to 529. Let's verify our answers using a calculator. 7 times 7 is equal to 49. Carry 4. 1 times 7 times 2 plus the 4 we carried is equal to 18. Carry 1. 1 times 1 is equal to 1 plus the 1 we carried is equal to 2. 17 squared is equal to 289.
Let's verify our answers using a calculator.
4 times 4 is equal to 16. Carry 1. 6 times 4 times 2 plus the 1 we carried is equal to 49. Carry 4. 6 times 6 is equal to 36 plus the 4 we carried is equal to 40. 64 squared is equal to 4,096.
Let's verify our answers using a calculator.
Are we all ready? Let's go to the tutorial room.
Let's go back to another special product. That is, the product of the sum and difference of two terms. For example, the quantity x plus y times the quantity x minus y. The two terms we're referring to are x and y. Their sum is x plus y and their difference is x minus y. Applying FOIL on the quantity 2x plus 7 times quantity 2x minus 7, we get 4x squared minus 14x plus 14x minus 49. O and I are the same but have opposite signs, hence their sum is 0. Thus, the resulting product is a difference of two squares. Thus, quantity x plus y times quantity x minus y is equal to x squared minus y squared. The two squares are the square of the first term and the square of the second term. They are joined by a minus sign. Can you give the products of these pairs of binomials orally?
To 49y squared minus 4.
Okay.
To 16x squared minus 25.
All right.
100x squared y squared minus 81.
Good.
$400 minus 9.
Okay.
$1,600 minus 1.
Okay. How will you express these products as the sum and difference of two numbers?
Quantity 40 plus 3 times quantity 40 minus 3.
Okay.
Quantity 90 plus 2 times quantity 90 minus 2.
Quantity 70 plus 6 times quantity 70 minus 6.
Quantity 50 plus 2 times quantity 50 minus 2.
You can even extend the shortcut to larger numbers like
Who needs a calculator?
right you are. Ancient mathematicians did not have calculators like we do now. Yet they managed to compute products of large numbers because of the characteristics of the numbers and the special rules for finding special products. Can you multiply this orally? 1004 times 996. If you can, it means you have learned some of the secrets of ancient mathematicians.
We won't be needing that now.
We can do this. 999,984.
Let's verify our answers using a calculator.
Great! Now see if you can make your own problems and apply this special product to impress your less mathematically inclined friends. Perhaps they will want to be as adept as you are with finding products of numbers mentally.
To 92 times 88. 90 plus 2 times 90 minus 2 is equal to 8,100 minus 4 equals to 8,096.
103 times 97. 100 plus 3 times 100 minus 3 is equal to 10,000 minus 9 is equal to 9,991.
405 times 395 equals 400 plus 5 times 400 minus 5 equals 160,000 minus 25 equals 159,975.
A binomial is the sum or difference of two terms. We found that the square of a binomial results in a perfect trinomial square. Two of the terms, specifically the first and the third, are perfect squares, and the second term is twice the product of the two terms. The middle term is twice the sum of the square roots of the first and third terms. Thus, if we have the product of two squares, we can find a third term to make a trinomial, which is the square of a binomial. For example, 25x squared and 49. What should be placed in the blank to make the trinomial a perfect square? We get the square root of each square. Square root of 25x squared equals 5x. Square root of 49 equals 7. Double this product is 35x times 2 is equal to 70x. Thus, the trinomial is 25x squared plus 70x plus 49. It is actually the square of quantity 5x plus 7. Can you answer the next two?
The square root of x squared is x. The square root of 81 is 9.
Okay.
X times 9 equals 9x. Double this product is 9x times 2 equals 18x. The trinomial is x squared plus 18x plus 81.
The square root of 36y squared is equal to 6y. The square root of 121 is equal to 11. 6y times 11 is equal to 66y. Double this product is 66y times 2 is equal to 132y. The trinomial is 36y squared plus 132y plus 121. Try this with us. Find the middle term of this trinomial.
Square root of 81y squared equals 9y. Square root of 25 equals 5. 9y times 5 equals 45y. 45y times 2 equals 90y.
The square root of 64a squared is equal to 8a. The square root of 49 is equal to 7. 8a times 7 is equal to 56a. 56a times 2 is equal to 112a.
The square root of 36b squared equals 6b. Square root of 16 equals 4. 6b times 4 equals 24b. 24b times 2 equals 48b.
Let us now discover the special characteristics of the square of a trinomial. For example, the quantity 2x plus 3y plus 5 squared, multiplying vertically using the long method, we get the square of a trinomial gives 6 terms. These terms have special characteristics. Since rearranging the addends does not change the sum, we can rewrite the 6th term so that their special characteristics are more easily seen. Number 1. These are the squares of each of the 3 terms of the trinomial that was squared. Number 2. The other 3 terms are double, or twice, the products of paired terms. This can be shown pictorially. Hence, if you want to square a trinomial, just number 1, square each of the 3 terms, then number 2, get twice the product of each pair of terms of the trinomial. We can also square a trinomial by expressing it first as the sum of a binomial and a monomial. 2x plus 3y plus 5 is equal to quantity 2x plus 3y plus 5. Squaring this, we have quantity 2x plus 3y plus 5 all raised to the second power is equal to quantity 2x plus 3y raised to the second power plus 2 times 5 times quantity 2x plus 3y plus 5 squared is equal to 4x squared plus 12xy plus 9y squared plus 20x plus 30y plus 25. Isn't this the answer we got earlier?
Yes!
Again, this is the same as the answer we got earlier. We can use this order of terms starting from the rightmost term in squaring a 3-digit number. But first, let's show the squaring using the place values of the digits. If we have a 3-digit number like 123 and square it, we can represent it this way. To check, we can multiply 123 by itself.
Can we also do that faster?
Yes, start with the rightmost digit. 3 squared equals 9. 2 times 3 doubled equals 12, carry 1. 2 squared plus 3 times 1 doubled equals 10, plus the one we carried over equals 11. 2 times 1 doubled plus the one we carried over equals 5. 1 squared equals 1. Thus, the square of 123 is 15,129. Thus, if we have a 3-digit number, which is actually the quantity 100a plus 10b plus c, and write it in an abbreviated way as ABC, the square, written from the rightmost digit, is we can number the stages as 1, 2, 3, 4, 5, starting from the rightmost digit. 1 refers to the units digit. 2 refers to the tens digit. 3 refers to the hundreds digit. 4 refers to the thousands digit. 5 refers to the 10,000s digit. Try these examples.
I'll try the long method first. Total is 60,025.
Let me try the faster method. They result in the same number, 60,025.
I think I can do the next one using the fast method. The square of 316 is 99,856.
The square of 143 is 20,449.
Okay.
3 squared equals 9. 1 times 3 doubled equals 6. 1 squared plus 2 times 3 doubled equals 13. Carry 1. 2 times 1 doubled plus the 1 we carried equals 5. 2 squared equals 4. So, 213 squared equals 45,369. Four squared equals 16, carry 1. 2 times 4 doubled plus the 1 we carried equals 17, carry 1. 2 squared plus 1 times 4 doubled plus the 1 we carried equals 13, carry 1. 1 times 2 doubled plus the 1 we carried equals 5. 1 squared equals 1.
Okay, you all did well. We've covered a lot.
Yes, we did. We studied a lot of quick math skills like multiplying the sum and difference of two terms.
We found the middle term of a trinomial to make it a perfect trinomial square.
We also did shortcuts for squaring trinomials.
We will share with our friends what we have learned. Maybe they will join us in the Hall of Brilliant Mathematicians.